Welcome to the Grid Mod Pod, brought to you by AEIC. In this podcast, you'll hear from the utility industry's top operations leaders on how their companies are working to modernize and improve our ever-evolving power grid. Thanks for joining us.
Hello and welcome again to another in the series of podcasts for the AEIC Center of Operational Excellence. Today we're talking about integrated system planning, and our guest today is Dr. Elizabeth Cook, who is the VP of Technical Strategy for the AEIC. So Dr. Cook, welcome.
Thanks. And for all of you that are avid listeners and confused by what just happened, today I'm going to be the guest, and here Francis Frank will be the host because we're ultimately actively working on an initiative within the AEIC Center for Operational Excellence, as Francis stated, bringing the industry leaders together to talk about critical action topics. And the one topic that, as Francis mentioned, that I'm super excited to talk about, and there's going to be a series of these episodes where I generally just share kind of where the industry currently is, how the various topics thread and interact with each other, and the ultimate goal is to really paint the larger framework that what is happening in our industry right now impacts all of the systems within the systems that we work in. So that's like my newest tagline, systems within systems. So today we're going to focus on one of our last workshops that we had where we talked about load forecasting and interconnection, which is a part of the integrated system plan. So thanks for having me.
So yeah, thank you. Thanks for taking time and coming on the show. So, integrated system planning has some big challenges. So tell me, from your own experience, what are some of these challenges, especially when it comes to DR, distributed energy resources, and the whole complexity about the bidirectional power flow and all that. Tell me what you think there.
Yeah. So, I think a lot of talking points and articles and various forms of information has been developed, created, and shared across our very large industry in regards to the enablement of distributed energy resources. And so it's been a big part of my life for the last really 8 years, where I was actively working for a utility where we were seeking to identify the methods or the processes that need to be put in place to really understand what this new set of technology will do to the overall operations of the grid. So not only just from the planning perspective, but from the operations perspective. So it's a very large topic. And so what I think is really exciting about some of the discussions that we'll be having with the AEIC leadership group is starting to thread the larger picture that, it's not just about enabling the edge of the grid. This really, what we discuss, determine, and identify as possible solutions, if we understand the bigger picture, could really help support the larger interconnection queue, which is also hot on topic in regards to our transmission generation queue. So I think, one thing that the industry as a whole, and that's external stakeholders and, internal utility resources, is there's a certain expectation of the visibility that we have to the overall performance of our distribution grid. And I think a lot of my discussions here on this podcast in the past has really talked about, there wasn't a need for these large system models to be developed for the distribution grid until really this new advanced technology and new way to create energy on site became available, and then ultimately now has become quite scalable in various subsets of our regions as well as really globally. So here we are as the utility employees trying to get ahead of what type of information and what type of qualifications do these certain pieces of new technologies that are new to everyone need to be aware of, consider, and what are the implications of how they interact with the grid. So when we talk about the complexities of, well, it's just a solar panel on a house. Well, that might be fine for just one, but then you have 10, then you may have 100, then you have 1,000. And the learnings that you gain if you get a head start is incredibly valuable. And really, we all, to each their own, must learn this from a people perspective, because there's so many utilities, there's so many grids. So that education, that knowledge needs to be gained within each utility. So I think your question was like, what is one of the biggest challenges is when you're in it and you're like dealing with it. It's a challenge in itself because it's new and you have to have an experience and see how this stuff works to be able to then champion and drive certain decisions in a certain process. And then even bigger than that is the communication plan and the ability to inform all those that want to be a part of the adoption of this technology. And so I think that's actually the most challenging, is how do we create storylines, documentation, documents that really create trust between all of the parties to really ground us in the fundamentals of the physicality of these technologies. And I think we're kind of all as an industry grappling with that. And we've been grappling it for about 10, 15 years, especially on the edge of the grid. But that takes you all the way back to what do we need to know for the bulk electric grid and all of these new technologies that are available. So that's a long-winded answer to it, but it's very complex. And I think the hardest part is the people and really identifying what processes will be impacted. And you got to know the process before you can impact the overall next step. So
you mentioned the people, right? And you mentioned leadership, but being in the industry, regulation have a lot to do with it. And especially if you're doing DRs, you're looking at third-party developers, different owners. So how can the utilities overcome these, regulatory and third-party coordination challenges?
Yeah, and I think that's also what's being identified in some of these discussion points is the organizations or the leaders that come to the table are really those that are in charge of ensuring the safe, reliable, affordable operations of the grid. So we really work to peel back the onion and focus on those technicalities and the functioning of the actual physical devices, which in itself is complex. But what we've learned by really kind of keeping that regulatory pressure outside the doors, it ultimately drives the technical experts' perspectives of the need or the urgency based on the regulatory mandates or regulatory guidance, however you want to incentivize utilities to do X, Y, create incentive for customers to do X, Y. So I guess it's really important that we do not lose sight that each individual utility shows up a little bit differently in the space based on what the external pressures are. And so it's very hard from a people processes perspective to get to the nuts and bolts if you don't remove that complexity, but also at the same time, you have to be aware of it based on the conversations being had. And so I think the way to solve that is to speak to it and to bring awareness of it. And then how do we, as a unified voice, create the language to really standardize how we see these certain devices integrating to the grid? And that can be a commonality. And I think getting to that baseline is probably the biggest challenge. And so I think we're making strides, especially in these forums, to really advocate and share the knowledge of one experience to the knowledge of many. And that's the kind of the beauty of it. And I think, just by being in the room and hearing kind of lessons learned, we're going to get to the technical part, which then allows us to speak with open transparency, open dialogue with the regulatory folks. So you kind of have that awareness, and then we're making strides in the right direction.
So, everything is evolving, right? So load forecasting is also evolving. Nowadays, we see the rise of electric vehicles, building electrification, data centers. So what strategies can be implemented to do these demand predictions?
So I think a big benefit of the conversation came into very tight focus of the power of data. So for any of those avid listeners here on the GridMod Pod, the key for us to unlock the current capabilities of our infrastructure and how we prioritize and take action on the existing performance fundamentally comes down to developing the right framework to have all of the disparate data sets that are currently existing and being created within the utility space to start talking to each other. So, wrapping up thinking about the interconnection thought process, there's a certain amount of data and information that we need from the customers that want to interconnect to the grid. And we have only learned by doing and then really realizing it would be helpful if we had this data. And so thinking about, how do we then forecast as a industry for 120 years? Fun fact, one of the first topics that the AEIC leadership spoke about in 1885 was, what are you all doing to predict the usage of our commodity that we are all creating, aka electricity? And so the discussion between the gentlemen that were owning these assets was like, well, our customers are very predictable. They wake up, they go to work, they come home, they go to bed. Our commercial and industrial customers, they want a certain amount. And so one of the asks was, when they returned to their next meeting, to bring the load curves. So from a load research perspective, we've gotten really good at predicting the predictability of us as humans. And so the dynamic change that's occurring in the last 10, 15 years is us as consumers, aka the customers of the electrical power grid, are becoming less and less predictable. And then also adopting, even if it's a small subset or a very large subset, a set of technologies that even removes some of the predictability that we are out of the equation because of the ability to generate on-site or nearby. And so now you have all of this capability. So when we talk about load forecasting now, 10, 15 years ago, it was how do we, or is even this new technology edge ultimately going to be a player in the bulk forecasting, which happens at the large generation transmission side. And we stop kind of those predictions and those forecasts at the substation level. So for those listeners brand new, you have your large generation, you have your transmission system. It steps down through a substation that goes into a distribution system. And so predominantly the industry has been very focused to meet this very large load, which is, we're talking like cities and, counties and states, and then ultimately national. So gigawatt worth. And so when we talk about forecasting down to the individual consumer, when does an adoption of 100 customers or 1,000 customers become a variable in that large bulk forecast? And so that's kind of been we've been sitting on that line where transmission folk dealt with transmission numbers and distribution on distribution, but we're seeing a lot of use cases where the impact of how the distribution grows from a load can ultimately drive some of the transmission. Some may say that's not happening at bulk, but there are areas where it is happening. And so what I think we've really grounded ourselves during our discussion is the need to have the infrastructure from a data perspective. So a place, this is really high level, to bring data back so that you can then sort it, convert it, and then create it into something that's digestible to us that make decisions. And so that infrastructure of all of that data to create these more advanced forecasts require talent as well as financial resources, but then the acceptance of this change. And I think when we talk about load forecasts, it's becoming very difficult to forecast based on predictability, which is what historical usage. And so there is a very large necessity to develop this data strategy so that you not only can ensure you're gathering the right data for when they want to connect, interconnection, to the ultimate like usage, so that you can create these very advanced calculations so that we can prioritize how we rebuild the grid. So it's exciting. So I don't know if I like clearly say that, but we all need to invest in a data strategy so that we can take in this enormous amount of data and use it to the advantage of our current infrastructure.
Yeah.
And then
So
also set us up for success.
that's definitely the answer there. So from a broader perspective, broader efforts, every utility really looking at grid modernization and how that modernization helps reliability and also resiliency. So ISP, or integrated system planning, how can that effort help that whole broader initiative or broader perspective?
Okay, let me see if I can do this. So, we came to the table to talk about what are the current utilities doing to unlock and enable various interconnection processes. And so I think what we learned from it is that technology, which is like the hardware as well as software that's required to really document, iterate, rinse and repeat, maintain, learn from, as well as the same for load forecasting. And so I think and really what I want to share on this podcast is the realization that as utilities that have owned these assets are now realizing that they're at a point in time where we must invest because of the age, but then also staring at this exponential load growth that we haven't seen for 50 years, having access to the current performance of the existing grid is a necessity, is foundational to the grid modernization journey. And so I think it's like, how do we as the industry leaders that understand just the assets as they are with the limited data help drive the language and the correct guidelines, best practices to implement infrastructure that can pull in an enormous amount of data. So you have to actually have the sensoring and the measuring equipment deployed. And there's a gradual growth here, right? A maturity curve. But like, unless you know about it, you can't actually walk the journey. So from a reliability and resiliency perspective, which is the core of what our expectations and what we're regulatory required to do, is we know to some degree, based on the limited data that we've achieved, and so by deploying the same infrastructure and data strategy for interconnection forecasting, if we have the same mindset and visionary North Star, we can then start quantifying our current performance without all this new technology, and then start studying the metrics of what is reliability, which, granted, we have industry standards we created 60 years ago, but now we can really get into the granular data of each individual customer. We can tie it back to the actual circuit, the phase, the load block, right? And then make more precise decisions on how we spend our capital and O&M and how we can utilize our customers in advantage for themselves and the overall system of the grid to defer or pivot or rethink certain projects as, the customers create new engagement. So all that to say is your reliability metrics are grounded in more truth. Not that they were untruth, but you only had a certain visibility. And now that you have a greater visibility, you have more levers to advance it. And then the other term, resiliency, is kind of like two steps, in my opinion. But resiliency means once the system does go down for reasons that are outside anyone's control, a motor vehicle accidents, critters, trees falling because they're old, not the weather, and then you have all your storm expectations, which I think a lot of us consumers of energy forget. There's a lot of things that can happen that really take the lights out that we can't control. But how can you bring the grid back, and at what speed? So one thing we got to do is get enough data to really develop and create universally adopted metrics of what the value of resiliency is to an individual, as well as to a utility, as well as to a community. A lot of work there, but you really can't make leaps and bounds until you have that concrete data. And then the other part of resiliency is because of the new technology that wants to interconnect and all of these ever-changing dynamic forecasts, could we start looking at the edge of the grid and fragments of the distribution grid as self-sufficient and more flexible because they have these new on-site energy sources? And so our solutions in our box become more available to bring back parts of the grids faster because we've created these isolated systems within systems. And that's somewhat nirvana. And a lot of people, I think, lose sight of that feasibility, but you can't get there unless you start. So to tie a bow on that, by effectively doing the same set of execution around your data strategy and the framework that's required, aka where your sensoring measuring is and the data that's coming back and the latency and really the set of inputs that can be standardized, you literally can derive efficiencies and change approaches and processes from the moment a customer wants to connect, having that full visibility of what that means and how that impacts, and can study it very quickly so there's not that long delay, all the way into providing the information for your forecast so that you can supply to your financial realm, to your regulatory realm, as well as your planning groups, all the way into the reliability of the grid itself. So looking at the performance metrics, as well as kind of thinking through that fleet of now new insights to drive how you prepare your resiliency, all the way into the room that's being asked to prioritize where their capital OM dollars are. So it's right there. And so now you just have to execute. Can you tell I get excited? That fundamental framework. And I think there's many of us that have started it, and the power of the voices to come together, we can really drive impactful changes for those that are just beginning to crawl, and even to support those that are mature and running with all of this new technology.
So
Did I answer your question? Am I doing good answering the question? Because that's always hard.
That leads me to my next question, because there's a school of thought, or two different school of thought, a top-down method and a bottom-up method, right? So when it comes to forecasting, so the integration of it, though, gives you that holistic, comprehensive view of forecasting. From your experience, where do you stand, and what is your view on that?
On accepting the top down or the bottom up, or just
that combination, that
space?
integrated view.
Right. So, and it's funny, I actually got in a couple of these conversations after the fact. So thinking about your mindset and where you sit within where the expertise or the unit for which you're leading or in charge of, those sitting in transmission may look to the distribution still as okay, you little child, you cannot really truly impact these large infrastructure needs and changes. And then I think even if you switch over to the distribution folk, where I think you could kind of think it from a maturity of coming into your own, the folks that have been and have all the experience of how to operate and develop and drive the reliability that we do have for a distribution grid, could even look at these new technologies and new ways of thinking as almost a nuisance, because there's a practicality of keeping the lights on and we're going to do what we've done. And so when you think about the conversation between, utilizing the top down, you stop at the substation. So quite frankly, any of the distribution folk that truly see a change in tide is that granular information no one's seeing but themselves. So their opinion of the top down is well, we have noticed that this isn't working to the level that we need to be able to accordingly plan our distribution spend and prioritization of projects. And so what does that mean is For instance, you could forecast top down to your substation node, and then from that perspective, it's done. But when you look at a distribution grid and all of the varying different communities, and they become their own fingerprint. So you lose sight that there could be a boom in a town that is fed by 5 circuits, and then you can lose sight the fact that you have population loss or a large manufacturing site that leaves. And so to have the top-down load forecasting, you lose sight of that granularity. So right there, it's broken. And I think it's only becoming more and more obvious to all is because we built the grid quite robustly in the last 60 years. And so we've been incrementally eating up that capacity and that flexibility in the distribution grid. So it's no longer a solution. And so just to the listeners, load forecasts typically predict a certain revenue stream, which then predict certain financial models, which predict what you're allowed and not allowed, or what you can afford and not afford from a prioritization perspective. So it's actually a big deal. And then along comes this now computational power, devices that are mini computers that have the ability to be communicated across Wi-Fi. And that data that was never available is now becoming very available. Now there's an investment and there's a lot of processes that need to change. But what that bottoms up analysis gives you is that more granular perspective in your forecast, but also your reliability, your capacity, your voltage health, and really how you then can designate these new interconnections in a way that's mutually supportive. And so here's that, what does that mean to that node from the bottoms up? It can greatly impact, if we do the right solution making at the distribution, that maybe the draw that the transmission is now seeing is less. And that ultimately helps maybe support a very large customer, such as, a data center, or defer the spend of a large generation plant, which I don't think we're anywhere near, but ultimately that could scale up. So I think both worlds need to exist, but both worlds need to be educated on the power of each other being a synergistic solution and not a one or the other. And so that comes down to that whole trust discussion, right? Do you have the right leaders that have certain expertise, realizing that they now are working together and not separate? And that is a whole discussion in our industry that's happening. And I think data will unlock that realization.
So
thank you for these great questions.
Cool. This is cool. I want to switch gears. My last 2 questions really on hosting capacity. It's a fun topic in the industry, and
Yes.
there are different perspectives on hosting capacity. So what role do hosting capacity maps and flexible interconnection agreements play in improving the efficiency and the speed of the interconnection process? What's your thoughts there?
So I think hosting capacity is a great buzzword, and that unless you're fully tuned in and vetted to what they are to date, what they were in the past, and what they can be, where I believe the conversation can be very short-sighted and limited. And so what do I mean by that? Is the idea of them is incredibly valuable and will be super helpful to do a significant amount of initiatives that are being driven or desired by either customer demand, but really the next set of innovators that have created certain technologies that were not possible 100 years ago, and now they are, and they want to be a part of this thing we call the grid. We should not demonize that, right? So we as a society should realize there's new technologies that, yes, we would like to adopt them, but when we're going to adopt them, we have to truly understand what that impact is. So going all the way back to our original thread, is there is a certain expectation of what all, aka all consumers of energy, believe the utility has from a data and a visibility perspective. And so I think there's a gap in our conversations that it will require the alignment of executive leadership, consumer advocates, and regulatory models to understand that fundamental technology and those advanced measuring and sensoring and the bandwidth of communication are all necessities. That's the grid mod journey, by the way, the foundation. To give the data to those that own the assets to have that full visibility so that you can run dynamic maps, which means that like almost every day, I mean, that's a lot of data, are being ingested into a power flow solution, millions of scenarios calculated, limiting and maximum, like minimum thresholds, maximum, minimum, are allowed, and then outputs are given to an audience that actually wants to know about it. That whole fleet of technology is like the nirvana. And so the next step is near real-time system planning, where you're actually doing what we do on the bulk transmission grid, is you're creating a snapshot of what tomorrow will bring and calculating the amount of energy that's required in these very granular customer-specific space so that the technology can play the way we want it to play. That requires an investment to get that insight. So when I think hosting capacity is a beautiful way to show and provide information to those that want to be a part of the solution. And where I think we've gotten lost is the expectations of delivering these maps was under this guise that we have all of this stuff. And the reason why the grid has been able to operate the way it's been able to is a beautiful design. You know, it's one-way power flow. You have a bulk generator, transmission, distribution, and we could calculate the number of homes and businesses. There's a certain resistance from the conductor size, a certain amount of pull from our customers, and you can do almost Ohm's law. So it wasn't difficult to plan to that predictability of us humans. But now that everything's changing, that visibility is now needed. So I think hosting capacities are a game changer, but we as a society have to understand the various components that need to be implemented, which have a cost to it, financially and human resources, which this whole industry needs lots of bright minds to help contribute to our efforts. So even if you throw all the money in the world, if you don't have the people to implement and construct the areas that need the infrastructure, we're going to be very limited in how we build out our grid. So anyway, to answer your questions, I think hosting capacities could be a very powerful tool, but I think we all need to understand why they were originally asked for, and then what the historical ones were actually saying. They're pretty static. They didn't have all the answers. Where we are now is very different for every utility that literally is working on this solution. So it means there's effort being given. And then that where we need to be is kind of what I played out. So you need that infrastructure, you need the people, you need the data, and then you have to have that computational power running to give that day ahead type snapshot.
So,
Thanks for asking.
I'm going to give you one last one, and, it's
Okay.
hosting capacity. I know in your role, Dr. Cook, as VP of Technical Strategy, you work with so many utilities, plus you do other work to show that the message for grid modernization, the message is out there. I will say that you're one of the biggest evangelists on this topic. So because of that, here's my question. Tell me, what stands out? What are some of the latest stuff when it comes to batching interconnections or hosting capacity that already stands out to you from an innovative perspective?
So wait, your question is like examples of some of these systems
Yep.
that have been implemented? Yeah, I think there's pockets. So I don't think anyone has the full span of capabilities, but I think there are a lot of first movers that have adopted the mindset of this data-driven decision-making power. And I'll just share, I think Alabama Power has an amazing strategy that they're setting up, and I hope they're going to be on one of my podcast episodes to share their incredible work. And it's really that data piping, the behind the scenes, to be able to facilitate that granular information, not only for hosting capacity and interconnections, but really for the full span of business. And then I think if you look to the West, who kind of have been under the most pressure for the longest in regards to the feasibility and understanding how to take on the incredible amount of customers that ask for this new technology, the West and Arizona and Hawaii, there's been a great movement in creating polls and the fundamental processes to pull that type of information in and to run these type of hosting capacity maps. So I think they're very close to some of this whole situational awareness that I spoke of, because they have systems in place where customers can apply online, submit their application, goes through that computational set of powerful solutions that I spoke of, and gives, the next day answer to those that want to connect. And so it even went, even further, one could say, is like now they're creating systems for which they're piloting. How do we create communication with our customers to manage various settings of load so that we can really create that edge dynamic of supporting each other from a individual distribution circuit. So, that has taken time. And I think a lot of, because customers drove fast, but I think we, the rest of the industry, kind of can reap the benefits of a lot of those lessons learned. And then I think there's a lot of utilities that have made great advancement in that hosting capacity map that can be found online. And I guess my only words of advice is become comfortable that your utility is working to be the friendly energy advisor. So don't take everything you see from the map as absolute truth, because your ask or perspective may have a lot of varying variables than what the overall set of assumptions and information that currently has to prepare that map. So it's not that the map's wrong, but it's, what are the current capabilities, and then make sure that what you're assuming is a correct assumption by having a conversation. So there's lots of maps that you can find across, I think, our states. It's really about really understanding the full information. So that's why I think I get really excited, is because I've seen many invaluable use cases and amazing innovative work happening within the utility. And it's all being driven by the bright minds and those that can think outside the box. And then those that have executive alignment and that go get it done kind of mentality, realizing it is a change. And as we all know, we don't like change, and just having that culture. So I've seen it many times, and that's kind of why I do this podcast, is to get the word out that we need to continue to build up and promote that innovative, creative thought of driving change. And it starts within the utility walls. So I've seen it many times over. Not to call anybody out. So I did call one out, but that's how excited I am about them.
I'm really happy once again to have you as my guest in this series. Before we close, do you have anything closing to share with the audience, or anything coming up, any sneak peek, anything?
I have to say, I'm supposed to plug and tell you to subscribe. Keep showing up to learn about some of the fundamental, amazing work that's being done in the utility space. And then in regards to the workshop series, the next kind of topics that we're approaching is data centers, which is a pretty hot topic. So that'll probably be our next workshop, and many more other topics to come. So I look forward to having the discussion with you next time, Francis.
So thank you, Dr. Cook. And once again, to the audience out there, thank you for joining us today.
That's a wrap for this week's episode of the GridMod Pod. Thanks for tuning in. We hope today's conversation got you thinking about new and creative ways to improve our power grid. Be sure to subscribe to our YouTube channel to be the first to hear new episodes. This podcast is brought to you by AEIC, the place where operations leaders come together to share knowledge and provide guidance to the electric utility industry. We'll be back with a new episode soon. Until then, keep powering on.